Hello aspirants, welcome back to our channel Food Tech Online. Hope you all are doing good. So today we'll be discussing GATE 2019 previous year question paper of food technology subject. So let us start. Liter has been used to prepare ice cream which yielded a finished product of 490 gram per liter. The percent overrun is how much? We have to round it off to 1%. So what are the things given? Weight of the ice cream mix, which is 870 gram per liter, and weight of the finished ice cream is also given, that is 490 gram per liter. So what is the formula of this percent overrun? It is weight of the milks minus weight of the ice cream whole divided by weight of the ice cream. So simply 870 minus 490 by 490, it is 380 divided by 490, or it is 0.7755. Now we need percent, so we'll multiply by 100, that is 77.55%. Now we have to round it off to one decimal place, that is 77.6 approx. And this percent overrun over here, it means that it will measure how much air, means by weight, is whipped into ice cream during the freezing. Now higher overrun means it is lighter, it is fluffier texture, which means it is cheap commercial ice cream. And lower overrun also, it means that it is dense, it is rich product, premium quality. So over here my answer is 77.6. Impaler in a fruit juice mixing tank is rotating at 200 rpm with a Reynolds number 10 to the power 4 more than. Density of juice is 1045 kg per meter cube. If diameter of the impeller is doubled and other conditions it remains constant, the power requirement of mixing will increase by a factor of. Okay, so over here it is turbulent flow. We can understand it is more than 10 to the power 4. That means Reynolds number, which is more than 10 to the power 4. It is turbulent flow. Now the power required to rotate the impeller, it is given by where this NP is my power number, which is constant for this turbulent flow. Rho is the density of the fluid, that is 1045 kg per meter cube, and N is my rotational speed, that is 200 rpm, and D is the impeller's diameter. So for initial power, we'll say P1 for initial. So everything will be like NP rho n cube d to the power 5. Now after doubling the diameter, say diameter is my D2. After doubling this, it will be equal to 2 of D, initial diameter. So P2 will be equal to NP into rho into N cube. Over here we'll just write 2 to the power, no, it's 2D to the power 5, or it is equal to NP rho N cube 32 D to the power 5. Now if P2 by P1 we will take, it will be equal to, I'll write full, NP rho N cube 32 D to the power 5 whole divided by NP rho N cube D to the power 5. So it is equal to 32. So in conclusion, we can say that this power scale with this D to the power 5 is turbulent flow, and doubling the impeller's diameter, it will increase the power requirement by the factor of 32. So my answer over here will be 32. By the factor of 32, it will get increased. Consisting of 20% husk has been milled to remove 6% bran during polishing. Now we have to assume that no other losses has been occurred, and yield percent of polished rice from the paddy is how much, and we have to round it off to 1% decimal. So first of all, we'll just assume 100 kg of paddy. You can also take 1000 kg, better to take in round off. So we'll assume over here 100 kg of paddy. Assuming 100 kg of paddy. Now, husk which has been removed is 20%. That means 20%. That means 20 kg of 100 which has been removed. Now, if a husk is removed, we're left with brown rice. That is 100 minus 20 kg. That is 80 kg is remained. Now, again polishing has been done, and in polishing we'll just remove the bran layer, and it has given 6% of the polished, that means brown rice. So 6% of my brown rice. 6% of 80, 6 by 100 into 80, that is 4.8 kg. Now the polished rice which has been remained will be it was earlier 80 and we'll remove, so remaining will be my 75.2 kg. Now total polished rice yield we have to calculate. It is the polished rice by the total paddy. Okay, we'll calculate the percent. So it is into 100. That is 75.2 by 100%, into 100. So it is 75.2%. And so my over here answer will be 75.2. No round off is needed since only one decimal place. So if there is no other losses, means only husk, that is 20%, and bran, that is 6%, is removed, and yield is based on the assumption of 100 kg. So over here my correct option will be 75.2%, which is my answer. Milk having density of 1030 kg per meter cube is homogenized with a pressure of 30 megapascal, given acceleration due to gravity as 9.81 meter per second square, and we have to assume that no pressure loss. The velocity of the milk flowing through the homogenizer valve will be how much, and we have to round it off to 2 decimal spaces. So first of all, we'll write what are the things given. So inlet pressure, will write P1 as 30 megapascal, and atmospheric pressure at the exit, it will be 0 pascal. Density, it is given to us as 1030 kg per meter cube. V1, it is negligible since the inlet velocity, so it is negligible, and V2, it is the exit velocity, which we have to calculate. So we'll use the Bernoulli's equation, that is P1 plus half rho V1 square, which is equal to P2 plus half rho V2 square. So Bernoulli's equation, P1 is half of rho V1 square is equal to P2 half rho V2 square. Now we'll just simplify it. P1 is equal to half of rho V2 square, since this is negligible, or V2 is equal to under root of twice of P1 by rho. Just we have to substitute the values. So 2 into 30 into 10 to the power 6, that is megapascal. So to pascal will convert. Then density is 1030 root over. It will be root over 58252.43, which is equal to 241.36 meter per second. So my answer is 241.36. Have been dehydrated from an initial solid content of 12% to the final solid content of 94%. Now, if the peeling and the other losses are to the tune of 10%, final yield percent of the dried chips per ton of fresh potato is taken will be how much, and we have to round it off to 2 decimal places. So, okay, if they have given us for per ton, per chips per ton, that means initially there is 12% in the fresh potato, and finally it became 94%, and there is a peeling loss, that is 10%. So we'll take 1 ton. So 1 ton is equal to 1000 kg. So what is the total loss? That is 10% of my this 1 ton, that is 100 kg. Now remaining potatoes is how much? That is 1 ton minus 100 kg, that is equal to 900 kg. These will proceed to my dehydration process. So the solids in 900 kg is 12% of my 900, that is 0.12 into 900, which is equal to 108 kg. Now these solids are conserved, means only water is removed during the drying. Now we have to determine the final mass of the dried chips, and they have given us final product is 94% solid. So remaining will is 64%, which is my moisture. So if I'll keep X as a variable for my mass which has been dried uh, chips, mass of dried chips, that kg, that is 94% of my X, and which is equal to my this 106 kg of the solids which is present in my remained potatoes. So X is equal to 108 by 0.94, or it is 114.89 kg, and we have to calculate over here yield percent. So yield percent, it will be calculated by the mass which has been dried by the chips and the initial mass of the fresh potato. So 114.89 by initial mass was my 1000 kg into percent, so it will be 100. So my answer is equal to 11.89%. 11.489%, or if we'll round it off, so it will be 11.49% answer. Percent bricks having specific heat of 4298 joule per kg Kelvin is being heated from 30 to 95 degrees Celsius for pasteurization at flow rate of 1000 meter per hour in a tubular heat exchanger. Now steam at 100 degrees Celsius is used as heating medium, which is converted into condensate at 100 degrees Celsius. Now if the density of the beverage is 1075 kg per meter cube and the latent heat of steam at the given temperature of 2257 kg per kilojoule per kg, the mass flow rate of the steam will be how much, and we have to round it off to 2 decimal places. Okay, so we have to determine the mass flow rate of the steam, which is given in kg per minute. So first, what are the things given? We'll write flow rate, that is 1000 liter per hour. If we'll convert it to minute, that is 1000 by 60, or 16.67 liter per minute. or meter cube per minute, we'll just again divide 0.01667 meter cube per minute. Okay, density, it is given 1075 kg per meter cube, and we have to calculate mass flow rate. So it is density into the flow rate, that is 0.01667 into 1075, which is equal to 17.92 kg per minute. Now specific heat they have given, that is 4298 joule per kg Kelvin, and temperature change, that is del T, from 95 to 30 degrees Celsius, which is 65 degrees Celsius. And latent heat of vaporization is 2257 kilojoule per kg, or it is 2257,000 joule per kg. Now steam, it will enter at 100 degrees Celsius and it will exist as condensate at 100 degrees Celsius. So there is no change in the temperature. So only phase is getting changed over here. So first of all, we'll calculate the heat which is required for the beverage. That is Q is equals to mCp delta T. We have calculated M, that is 17.92 into 4298 into 65. So this is equal to 5005,190 joule per minute. Now we have to relate this heat to the steam mass flow rate. Means we have to provide a steam outcome from its latent heat. So Q steam will be equal to my mass flow rate steam and the latent heat of fusion, vaporization, and we have to assume that no heat has been lost. So it is equals to Q by HMG, or it is equal to 5005,190 by 2257,000. So it is equal to 2.22 kg per minute. So by energy balance, we know that heat which has been absorbed is equal to heat which has been released by the steam condensate, and we have assumption that no heat loss has been occurred and steam it is fully condensates as 100 degrees Celsius. So over here my answer is 2.22 kg per minute. %, relative humidity, and saturated vapor pressure is 7.375 kilopascal, and we have to calculate humid volume of air and round it off to 3 decimal places. So temperature 40 degrees Celsius, or it is 313.5 Kelvin. Relative humidity 60%. Saturated vapor pressure, PSAT, that is 7.375 kilopascal. We have to calculate humid volume. Okay. So percent relative humidity, we know that it is PW by Psat. Value of Psat we know, relative humidity value we know, that is PW is equals to 60%, or we will write 0.60 into Psat. Okay. Percent RH into Psat, or 0.60 into 7.375, or it is 4.425 kilopascal. Now since we are having PW value, we'll just put it and calculate H. So H is 0.622 into PW by P minus PW, or 0.622 into this, we got the value 4.425 by P is 101.325 minus 4.425, which is 0.0284. Now we know the formula of humid volume, that is 22.41 divided by 273, 1 by 28.97 plus H by 18.02 into T. Just will put the value of T and H over here. 22.41 by 273, 1 by 28.97 plus 0.0284 by 18.02 into 313.5. So calculating this, we'll get 0.1185 into 273 into 313.5, or 0.927 meter cube per kg dry air. So our answer will be 0.927. Meatball with 60% moisture, 35 degrees Celsius, is being done in an air blast freezer which is maintained at minus 45 degrees Celsius. Now it is given that latent heat of fusion of water is 333.2, thermal conductivity is 1.5, convective heat transfer coefficient is 40, and density is 980 kg per meter cube. And initial freezing temperature of meatball is minus 10 degrees Celsius. We have to use the Planck's equation and calculate the freezing time in hour and round it off to 2 decimal places. First, what are the things given? Diameter, that is D, 100 mm, which is equals to 0.1 meter. Moisture content is 60%. So latent heat of fusion, L, will be 0.6 into 3.2, that will be 199.92 K. or we can write 199920 joule per kg. Density of food is 980 kg per meter cube. Initial temperature, that is TF, is minus 10 degrees Celsius, and freezer's air temperature, that is TA, is minus 45 degrees Celsius. So temperature difference will be TF minus TA, that is minus 10 minus of minus 45 degrees Celsius, which is 35 degrees Celsius. Thermal conductivity, Kf, is 1.5 watt per meter degree Celsius. Convective heat transfer coefficient, that is H, 40 watt per meter square Celsius. Now Planck's equation, that is Tf is equal to Pf by delta T Pa by H plus Ra square by Kf. Now since spherical is given, so for sphere P is 1 by 6 and R is 1 by 24, the shape factors. So we'll just put the values. Tf is equal to 199920 into 980 by 35 into 0.1 by 6 into 40 plus 0.1 square by 24 into 1.5. So we'll get TF is 3888.78 by 3600 for 1.08 hours. So our answer will be 1.08 hours. With this, we have completed GATE 2019 previous year food technology question paper. Hope you found this video helpful. Till then, thank you and enjoy learning.